Hello guys, welcome back. Today we are going to understand today Leetcode question. So let's see what we have today in the Leetcode question. Okay, so today question we are saying this question is 404 about sum of left leaves, right? So let's go through this and let's try to understand what the question is saying. Okay, so the question is saying we have to find the sum of all the leaves, right? That is having left leaves, right, not null. And if that is not null, so we will what we will do, we will calculate all those values that is having here data, right? Like see, we have 3 as a root node, right? And 3 has 2 children, 9 and 20. So we will store 9 as a sum, right? And then we will move to the 20 and we'll see 20 have 2 children, so left children we will count and we'll have 15 now. So 9 and 50 is 24, right? That is why you can see output is coming 24, right? So in this way we will try to navigate and build to implement, right? So first of all you have to learn that see how we are going to understand this left tree. We are going to store in some variable like sum or any other place, right? So it's really important to understand the logic, right? So now 9 we have and 9 doesn't have here another leaves, right? Like you can say children's, right? Left and right, if you'll see here, it is having what? Null, right? Similarly, if you'll go for 15, it doesn't have any children, no leaves, so we can say we can store somewhere, right? Like that we have to see and we will go through one by one. Okay, so let's try to understand here what I'm trying to say. I'm saying if we have some, you can say trees, right, like that. Okay, so tree have left children and right children, that is for obviously, right? So if children has here null as a left, right, and right as a null, right, then only whatever the value will we have here on the node, right, that will be stored on the sum value and will return that sum value. Okay, so that we have to look for. Okay, so let's go to the code and try to understand what we have done here, right? So you can see here, right? So method we have given what? We have given one method, that is root here at line number 18, right? So if the root is equal to null, means we do not have any nodes in the tray. So this is the base case. If we do not have any nodes apart from given, right, and given is also null, right? So if it is null, we'll return 0, right? That is base case. Now we will move to we are doing actually as a if you remember tree traversal, in order, pre-order, post-order, like that. What we will use? We will use stack, right? So we'll take a dequeue of tree node stack and we will put the root first, right? And we will check if while loop having what? Empty, stack is not empty, then what we will do? We will pop the first node, right? That is what? Our root. So this is, we can say, node or current node, we can say, right? So now what we will check for this node that we have pushed just now, if it is having left children, right, then what we will go for? We will check its sub children that we are talking about. Node dot left we will do. If it is having left children is null and right children is also null, means this is the leaf node, you can say, right? It doesn't have next children's, right? Grandchildren is not there. So we will store the node dot left value on the sum, right? And otherwise we will push the, you can say, on the stack, right? If it doesn't have the leaf children, then till that we will move till the end, right, until we find the leaf children, right? And then what we will do, we will move on the we'll check on the right side, right? If it is not null, then we'll push the right node into the stack, so that we will iterate and we'll go to the right children and we'll find its right children's having left or not, right? So like that it will go into the loop, and then we will return the sum, right? So this is the same way that we are doing for the traversal, right? So in traversal we were using in order, post order, pre-order, any order you will use, but you have to make one only condition, that is for line number 28, that we were using node dot left equal to null and node dot right equal to null. It means children's are null, right? It means this is the leaf node, and then we will store onto the sum, right? We will try to store each time. So like that we have to do, okay? And for the you can say time complexity and space complexity, it will remain same, because O n square, O of n, we can say number of nodes we will move, we will iterate, and for the same we will use O of n as a space complexity, right? But if you want to optimize that, you can use Morris traversal, right? And you can put like, first we will traverse, you can say first we will traverse on the node, and we'll check if it is having you can say pre-node, right? Sorry, pre-node means if the node contains left subtree, then we will iterate and we will find the rightmost, right? And once we find the rightmost, we will put the current there and we'll go for the next, right? And if doesn't have that subtree, right, means we will put the node value onto the you can say result. Like that we will do, we are doing the Morris traversal, right? Let me know if you don't know the Morris traversal, and then we'll go for, okay? Thank you guys, thank you for watching this video. Please let me know if you have any doubts in the question. Thank you.